Alright guys, today we're going to learn about simplifying rational expressions. You've previously learned how to factor, a review of factoring, so we're going to use that today also. So first we're just going to talk about what it is. So a rational number is any number that can be written as a quotient of two numbers. Example would be fractions. So like 1/2, 3/9. 12/16. Okay, all of that are rational numbers. Whoops. Lord. Okay, so that's rational numbers. Now, a rational expression is a ratio of two polynomial expressions. So it's the same thing, except now we are adding variables. So an example would be 5x plus 3 over 2x minus 5. You can even have 1 over x as a rational expression. As long as x is in the denominator, you're a rational expression. Okay? So like 2x minus 5 over x squared plus 2x plus 4. Okay? All rational expressions. Now, just like rational numbers, you cannot have 0 in the denominator. Okay? Just like when you were learning slope and all that stuff and you had 3 divided by 0, that was undefined. Okay? So whatever makes our denominator 0 is what's undefined. So a rational expression or function. So therefore, we must... The students always say there's a mistake in my worksheets. Therefore, we must state where the expression or function is undefined. And how do you find undefined? All you do is set denominator equal to 0. And that's where x can't equal. Okay? Alright. And we're going to talk about what that does with the graph later. So, I want to state where the expression or function is undefined. So again, to do that, you set the denominator equal to 0 and solve. So 2x minus 5 equal to 0. If you want to be correct, you can put not equal to 0 because that's what we're trying to find. So we add 5 on both sides. We got 2x cannot equal 5. Divide by 2. So x cannot equal 5/2. So x can equal any number except 5/2. Okay? Now this one, when I set it equal to 0, I can't solve it like I just solved a minute ago. You have to factor it. When you have a b term and an a term, you have to factor. So a squared term and a linear term. Alright? So you need to figure out what multiplies to give you 7, negative 7, and adds to give you 6. Well, I know the only thing that multiplies to give you 7 is 7 and 1. Okay? Now, I want a positive 6, so that x has to be positive, that 7 has to be positive, and the 1 has to be negative. That's the factoring part, but then you're solving, so you have to set each parentheses not equal to 0. Okay? So we solve, we subtract 7. X cannot equal negative 7. And x cannot equal positive 1. Alright, so there's two values here that x can't equal. Okay? Alright. Alright, so the next one is state where it's undefined. This one's already in factored form for us, so that's good. So we're going to set each parentheses equal or not equal to 0. Okay? So then we solve. This one's going to have an extra step. It's going to be 2x cannot equal negative 1. And then we divide by the 2. So x cannot equal negative 1 here. Add the 4 on the next one. And x cannot equal 4. So x cannot equal 4, nor can it equal negative 1/2. Okay? So you have to start stating where the denominator is undefined. Alright? Especially on handwritten stuff. You know, when we do study Allen and stuff like that, I think it's a whole separate section for that. Okay? Alright. So, let's move on to simplifying. So simplifying is, so a rational expression is simplified when the numerator and denominator have no common factors other than 1. That means you've canceled all the common factors that are on top and bottom of a rational expression. Okay? So how to simplify a rational expression? Well, oh, I hit enter up there, so that's why. But here are the steps right here. Okay? So first, I need you to factor out the GCF if there is one. Factoring out GCF and factoring completely is the same thing, but I know myself, I always forget that GCF sometimes, and then when you go to factor, it messes it up. So I like to put it as a step. So factor GCF out if there is one. That's the greatest common factor. That means every term has something in common. So example of factoring out a GCF would be 2x plus 10. Well, both terms, because a term is separated by addition or subtraction, but both terms have a 2 in common. So I can pull a 2 out. And when you pull a 2 out, it's like dividing each term by your term. That's what factoring is you're dividing each term by that. So I'm dividing this by 2, dividing that by 2, and factored would be 2 times parentheses x plus 5. Okay, that's what factoring out a GCF is. That 2 is the GCF. Next, if after you factor out the GCF, if you can factor some more, but long as between the first 2 steps you have factored that rational expression completely, you're done. After you factor and it's in factored terms, then you're going to cancel out any factors that are in both numerator and denominator. They can't both be in the denominator and they can't both be in the numerator. They have to be one in each. So one has to be in the denominator and one has to be in the numerator. Okay, that is what that means. After you cancel those out, then you write new expression without the common factors. Okay, so we are going to do 11 problems. All right, around 11. So I want to do a flashback kind of start off with one that you have seen before. When you probably, I don't know, in some lower math, you've probably seen it. Bless you, Tinks. All right, so first step, find any GCFs. Do they have anything in common? Well, 7 has nothing. You can't factor 7. Now, factoring, you can factor a squared. Okay, and I'm going to do it just to show you how stuff cancels out. But a squared means that it is a times a. B cubed means it's b times b times b. Denominator 21 can be factored because it's not prime. That is 7 times 3. Okay. A to the 5th is a times a times a times a times a. And then you have just b. All right. Now, to factor completely, you cancel out any common terms that are on top and on bottom. Well, I have a 7 on top and a 7 on bottom. Now, did I cancel that negative out? No, I didn't. So that negative is still there. Now, if you had had a negative 7 on the denominator, then you could have canceled that negative out. All right, I have 2 A's on top and 5 on bottom, so I can only cancel out the 2 because they've got to be both on top and bottom. And I can only cancel out 1 B because there's only 1 B on bottom. So, I still have the negative. I have 2 B's left, so we can write that as negative B squared. Divided by, I have 3 A's left and a 3, which would be 3 times A cubed. And that will be your answer. Okay? All right. Next one is going to be 2. It is going to be 35xy squared over 14y squared z. Okay, I put a line through my z so you know it's a z, not a 2. All right. All right, so 35 can be factored as 5 times 7. X is just x, and y squared is 2y's. Okay. 14 is 2 times 7. Y squared is y, and then you have just your z. All right, so now I'm going to go in there and cancel. I can cancel the 7 out, right? Can't cancel the x out. I can cancel both the y's out. Can't cancel the z. So I have 5x over 2z. Now, if you have something that cancels out everything on top and bottom, your answer is not 0. Your answer is 1. because, so side note, you always have those. 2 divided by 2 is 1. Therefore, 3x divided by 3x is also 1. You can also say x plus 2 over x minus 3 over x plus 2 over x minus 3. Isn't that the same thing on top, on bottom? That also equals 1. Okay, so if everything cancels out, your answer is not 0, it is 1. All right, I wanted to say that. Now, also, if you remember your law of exponents, okay, I want to come back here and see these. Remember, you subtract your exponents when you're dividing them. Well, here, you would have subtracted the 2 minus 5, and that would have gave you a to the negative 3, and then to make that negative 3 positive, it goes on the bottom. And then b, you would say 3 minus 1, and you would get a squared, and it's or b squared, excuse me, and it's still on top. Okay? And remember, moving exponents from top and bottom make the exponent change signs, not the coefficient. Okay? Alright, so it's a quick Math 2 lesson. I do believe it's Math 2. Alright, number 3 is going to be 3x minus 15 over x squared minus 7x plus 10. Now, factor GCF out first if there is any. And there is. If you look, I have a 3 and a 5 and a 15. Well, they both have a 3 in common. So we're going to pull it out. 3x divided by 3 is x. Negative 15 divided by 3 is negative 5. Now, I do want to show you, so you watched videos yesterday of reviewing how to factor a polynomial, different ones. I want to show you how you can use Desmos sometimes. All right, now it does not always work, but it sometimes works. Okay, so Desmos, so a factor is basically where the graph crosses the x-axis. That is really all a factor is. Okay, well, simplified. So that denominator, x squared minus 7x plus 10, I want to factor it, and I want to factor it using Desmos if I can. So I type it in, x squared minus 7x plus 10. Now, if it crosses the x-axis at a perfect whole number, or sometimes a decimal, then you can put it in factor form. So, right here, where it says 2 and 5, those are my factors. It's going to be x minus 2 and x minus 5. Okay? And we did that in the polynomial union when we wrote a polynomial from a graph. Remember, we found the roots, put it in factored form. That's all you're doing, guys. Okay? So you actually know how to do it. It just hasn't been put in these terms. So, when I go back to the graph, it is x minus 2 and x minus 5. So x minus 2 and x minus 5. And if you want to make sure you're right, come over to the side, box them in. Whoops. X minus 2, x minus 5. Well, x squared, that's negative 7x, negative 7x, that's positive 10, positive 10. All right, so Desmos can help you factor if they're nice, pretty factors. All right. So, next step is to cancel out any common factors on top and bottom. Well, what do I have in common on top and bottom? If I can get my pen to work. I have an x minus 5 and an x minus 5. They're canceled. So now my answer is 3 over x minus 2. Okay? All right. Number 4. This is 2x squared plus 14x plus 12 divided by 2x plus 12. Now the top, is there a GCF? Yeah, there actually is a GCF. Each one of these terms can be divided by 2, so therefore I can pull a 2 out. And I'm left with x squared plus 14, that is 7x plus 6. Does the denominator have a GCF? Yeah, both of those are also divisible by 2, so I have x plus 6. Well, you got a 2 on top and bottom, don't you? Go ahead and cancel those out. I mean, they're going to get canceled out anyway. Might as well do it. You can try to factor this numerator with Desmos. Let's see if it'll give us our factors, okay? All right. So we're going to go to Desmos. X squared plus 7x plus 6. And what was it? Plus 6. So plus 6. And look, I can. X plus, remember you do opposite. X plus 6, X plus 1. Okay? So X, whoops. X plus 6, X plus 1. It does not matter what order you write them in. Over X plus 1. So we've already canceled out the 2. Now, I can cancel out the X plus 6's. And my answer, if there's no denominator, you can just write it as X plus 1. Now, that brings me to another side thought. If your numerators cancel out and you're left with just the denominator, so if you look here, this X plus 6 cancel, you can't get rid of a numerator. You have to always have a numerator. This would be 1 over X. Okay? So, denominator can go away. A numerator cannot go away. Okay? All right. Number 5. So this is 4x squared minus 6x over 2x plus 2xy. So you can factor in terms even with variables, okay, as long as they have that variable in common, all right? So this is the GCF. I got a 4 and a 6. So the biggest number that can go into both of them is 2. They both have an x. You always pull out the lowest amount of your variable. My lowest amount of this variable is just x. And when you factor, you're going to subtract those exponents, okay? So you're going to divide the coefficients, subtract the exponents. So I pull a 2 out, and I get 4 divided by 2 is 2. X squared divided by x is x. 6 divided by 2 is 3. And then x divided by x, it just goes away. Well, it goes to 1. But divided by, both of these have a 2 in common, so we're going to pull a 2 out. They both have an x, but they both do not have a y, so I can only pull out a 2x again. So when I pull that out, now, same thing. Remember, you're dividing. 2x divided by 2x is 1. That term does not go away, all right? Plus 2xy divided by 2x is just y. So the only thing here that I can cancel out is my 2x's. So my answer is 2x minus 3 divided by 1 plus y. All right, number 6 is going to be x minus 2 over 2 minus x. Now this one's really a trick I want to teach you guys, especially before you go to pre-cal and calculus and you learn a lot of tricks. Okay, so you see you've got x minus 2 over 2 minus x. You want to think they're the same, but if I put it in standard form, I'd have x minus 2 over negative x plus 2. Well, if you look, isn't the denominator just the opposite of the numerator? Right? This is negative x, that's positive x, that's positive 2, that's negative 2. So if I was to pull out a negative in the denominator, just factor out a negative 1. Remember, factoring is just like dividing. So if I divide each term by negative 1, negative x divided by negative 1 is positive x. Positive 2 divided by negative 1 is negative 2. Don't I have 2 common factors now on top and bottom? Okay, now that's a trick that I just want you to say, hey, I taught it to you. Okay, so just know that you can pull a negative 1 out if they're exactly opposite of each other. So now I can cancel out that x minus 2. And I'm left with 1 over negative 1, which is just negative 1. Okay? All right. Number 7. Okay, number 7 is going to be x plus 1 times x minus 5 over x minus 5 times x squared minus 1. Now, again, you learned factoring yesterday. You need to be able to recognize your difference of squares. Okay, difference of squares is when it says x squared minus a perfect square. So your perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and 169. I mean, I think you should go all the way up to 15, so 14, so it's going to be then it'll be 196, and then it'd be 125. Those are all perfect squares. So if you ever see x squared minus a perfect square, you can factor it by the plus and minus of taking the square root of that last term. Okay? So x plus 1 times x minus 5 over. Now, if that was x squared plus 1, you couldn't factor it. It has to be difference, subtraction. So the square root of 1 is 1, right? So it's going to be x plus 1, x minus 1. So, whoops. Let's fix that. So, I don't know why it's doing that. So, side lesson from yesterday. So if you have x squared minus 16, well, what's the square root of 16? Plus or minus 4. So x plus 4, x minus 4. X squared minus 100. Well, the square root of 100 is x plus 10, x minus 10. Okay? So, anytime it's a perfect square and it's a subtraction, that's how you factor it. Alright. Now, to find, now you got to cancel out common factors, right? So my common factor is x plus 1, x plus 1, x minus 5, x minus 5. Remember I told you when the numerator goes away, you still have to put a placeholder of 1, and then x minus 1's left on the bottom. So that's your answer. Alright. Number 8. I don't know why it's doing that. Alright. Number 8. It's going to be x squared plus x minus 12 over plus 7x. Alright, so if you want to factor it, you can, because you know 4 and 3 give you negative 12, and it also will give you 1. And that needs to be plus 1 minus 3. Or you can look at Desmos. So when I go to Desmos and I type this in, x squared plus x minus 12, it crosses at negative 4 and positive 3. So that's x plus 4, x minus 3, x plus 4, x minus 3. Okay, same thing. Do with the x squared. It's x squared plus 7x plus 12. And I get x plus 4, x plus 3. So x plus 4, x plus 3. Another cool thing you can see to simplify is type on top and the on bottom one. So let me write the top one. And the factors you're going to cancel out are the ones they have in common. So it's where they intersect. So where the numerator and denominator intersect on the graph is the common factor. Just something neat. Okay, so that means I'm going to cancel the x plus 4's. And I'm left with x minus 3 over x plus 3 as my answer. Okay? Alright. Number 9. It's really going to do 10. So number 9 is x squared plus 6x plus 9 over x squared minus 9. With no GCFs. Okay, I know I haven't been talking about that. See, as I go, I keep forgetting about GCFs. So I'm going to factor the numerator. So I'm going to put that up here. X squared plus 6x plus 9. Oh, I put 22 up there. Now, this also goes back to the polynomial unit. Because, oh no, it only crosses once. Well, it doesn't cross, it touches, right? Remember when it touches, it's a double root. So that is going to be x plus 3, x plus 3. It's a double root. That's why when you look at the graph, you really need to know what you're looking at. We spent a unit on that's why we spent a unit on graphing polynomials, okay? So if it touches the x-axis, it's a double root. Now, this is a difference of squares. What's the square root of 9? Plus or minus 3. So it's going to be x plus 3, x minus 3. Well, who can cancel out? let's see, x plus 3. Now, has to be one pair per cancel out. So can I cancel out this guy right here? No, he does not. Now, if there was 2x plus 3's on the bottom, you could have. But it only is 1 for the top, 1 for the bottom. So my final answer is x plus 3 over x minus 3. Okay? Alright, last one, number 10. This is going to be 4x squared plus 8x over x squared plus 6x plus 8. So when it's two terms, you can do a GCF. That's what you should look for anyway. So 8 and 4 have 4 in common. X squared and x, remember, pull out your lowest ones. My lowest is x. So then I'm going to get x plus 2x, or plus 2, sorry. Then, let's go to decimals if you want to. You don't have to, but why not? So that's x squared plus 6x plus 8. Oh, forgot the 6. So my factors here are x plus 4 and x plus 2. So it's going to be x plus 4 and x plus 2. But the only thing I can cancel out here is x plus 2, x plus 2. So my final answer is going to be 4x over x plus 4. Alright guys, so head on over to Canvas. You're going to be doing, well, you can head over to Study Island if you want to. Or you're going to have a Study Island after this. But if you have any questions, let me know. Email me. Alright, bye guys.